Alright, this video is about using transformations to graph quadratic functions. We're going to transform quadratics, and we're going to use this vertex form of equation to see what changes happen to the graph. So we know about linear functions that are y equals mx plus b. Okay? Now we're learning this new form for quadratic functions, which is a times x minus h squared plus k. And notice that for quadratic functions they all have a squared. Okay? It's the variable part squared. So the parent function for a quadratic is f of x equals x squared, and the shape of the graph is a parabola. Okay. Now you can graph these parabolas by plotting points, by plugging in and making a t-table to graph them. Okay. Or you can graph them by doing transformations to the parent function f of x squared. F of x equals x squared. So let's talk about some of those transformations. A horizontal shift of h units happens when the h value is added or subtracted to the x inside of the equation. So if x is less than 0, then it moves the graph to the left. And if h is less than 0, it moves to the left, and if h is greater than 0, it moves to the right. And that's actually unexpected. You see a negative h in here, you think it would move it. You would think it would move it left, but even though you have a negative h, it actually moves it to the right. We talked about this before with transformations. Okay, and then we have the k value. The k is added outside of the parentheses, not inside to the x, but outside. And you can see that when you add a plus k, it's moving it up, and if we were to have a minus k, it would move it down. Alright, so this particular slide here, this is really important. Please make sure you write this down. So this is breaking down for us what happens in this formula. Because the vertex is translated h units, h horizontal units, and k vertical units from the origin, the vertex is hk. So when you look at this, h is telling you the horizontal translation, k is telling you the vertical translation, hk is the vertex. And then A is going to indicate, it could be a reflection, okay? It could be a reflection across the x-axis, or it could be a vertical stretch or compression, is what we learned from A. So please make sure that you have this information about what all of these letters mean written down in your notes. So now, if you look at the original one, it's interesting to note that the original parent function, f of x equals x squared, can still be written in the same form with an a and an h and a k. It's just that with this one, the a is 1 and the h and the k are 0. So that's just a helpful hint. Okay, so let's see if we can apply those transformations to this graph and see how it happens. So what transformations have happened to this graph from the original? Well, first thing that you need to do is identify on the inside here what the h and the k are. And I can see that the h value is 2 and that the k is 4. So what that means is that the graph has moved 2 units to the right. So it has a negative 2, it's going to move over 2 to the right, and then it's going to come up 4. Okay, the vertex, the new vertex, if you look at this graph, is at 2, 4 up here. Okay. All right, how about this one? Now this one has a plus inside here with the 2, so it's not gonna. So I'm expecting it to move in the opposite direction. Now I can rewrite this plus as being minus a negative, so that you can see that the negative is part of the formula, and that I would have to have a negative 2 in here, because negative times negative would work backwards to give me that positive. So my h this time is actually negative 2. And then I have a minus 3. So this time we're moving to the left 2, and then we're going to move down 3. So the new vertex is at negative 2, negative 3. Okay, so now let's look at some stretches or compressions. When you put a negative inside the function, it's a reflection across the y-axis. When the a value out front is negative, that reflects the graph to face down. So instead of facing up, it faces down. If the value of a is in front is a value that's less than 1, Okay, so if we have a fraction, then that compresses the graph and makes it fatter, okay, or wider. And if the value of a is a value that's not a fraction, like if it's a whole number, it's a value greater than 1, then that is going to stretch the graph narrower, okay, or taller. So let's look at an example of that. Here I have a 1/4. Oh, first I have a negative. Okay, so negative should reflect this to go down. Whenever I have a negative, that's going to be like a frown face going down. And then because it has a 1/4, and this value is less than 1, I'm expecting it to make the graph wider. Okay, because it's a negative, we have a reflection across the x-axis, and because it's 1/4, it's a vertical compression by a factor of 1/4. So you can see that the red one is fatter than the original. Okay, so here I have a value of a 3. Okay, so because I have this 3 in front, and it's a value that's greater than 1, I'm expecting this to be to make the graph narrower or taller. So this is how the graph changes when I do a multiple of 3. So that's the difference between those. If a parabola opens upward, it has a lowest point, and if it opens downward, it's going to have a highest point. So we're going to have a minimum or maximum at where the vertex is. Now that vertex also is a place where the graph is symmetrical around. So you can see that for all these parabolas, they're the same on the left side and the right side. They're symmetrical. There's a line that's the axis of symmetry that always goes right through the vertex. So the axis of symmetry happens at whatever the h value is. So x equals h is the axis of symmetry. So make sure you have that down in your notes too. The axis of symmetry, it happens at x equals h. So where is the axis of symmetry for this one? Well, the axis of symmetry would be at whatever value h is. So I need to look in here and determine what h is. And I can rewrite that plus as minus a negative. My h value is -5, so that's where the vertex is, where the axis of symmetry is at x equals -5. The vertex of this is at hk. The h is -5, and the k would be -8. Alright, so now let's see if we can use our parent function and write what the equation for this graph would be if the parent function is vertically stretched by a factor of 1/2 and then translated 2 units left and 5 units down. So let's take each of those things and say what they would happen in the function. If it is stretched vertically by a factor of it looks like I say a factor of 1/2 up here. We have a factor of 4/3 here. That would be a typo. Let's say it's stretched vertically by a factor of 1/2. Instead of having a be 4/3 here, we need to have a be 1/2. Okay, and then translated 2 units to the left would mean that h is going to be -2. And if it says, since it says 5 units down, we're going to let k be -5. So we just need to plug those things into our vertex form for the equation. So here's our vertex form. We're just going to substitute 1/2 for a, -2 for h, and -5 for k into this equation. And then that is going to be our equation. We can just simplify that down by, this is a plus minus a negative here turns to a plus. Okay, so that would be our equation. Okay, great. So last one here. On Earth, the distance d in meters that a dropped object falls in t seconds is approximated by the d of t equals 4.9 t squared. On the moon, the corresponding function is d of m t equals 0.8 t squared. What kind of transformation describes the change from the original distance with respect to time? And what does the transformation mean? So they're asking us to compare these two and see what kind of transformation happens between the Earth and the Moon. What does that actually mean? So if we examine both functions in vertex form, we can see that they both have the h and k to be 0. The only difference is that one has 4.9 multiplying by 4.9 and the other one is multiplying by 0.8. So the a value has decreased from 4.9 to 0.8. So that we know that the a value is our vertical compression. So we can figure out how much it changes by comparing them, by dividing those two numbers. If we divide them, we can see that that how much did it decrease by? It decreased by a factor of 0.16. So an object dropped from the moon falls at about 1.6 times as fast as an object dropped on the Earth. Okay, so that example was just to show you that we can compare functions when they are written in vertex form. So we learned about parabolas and vertex form of a parabola. Vertex form. Okay.